Hi there, in this video I want to show you a very interesting device I received for a review. I did not pay for it, so for full disclosure I mark this as a paid promotion. This device is called ConsoleCast and basically connects a serial link to a Wi-Fi network. It comes from the developers called NickStick Design in the Netherlands, and this is their website on ConsoleCast, which has a vast amount of information. The idea is, as shown here, that you can connect all kinds of devices with serial interfaces and access them from your laptop over a Wi-Fi link by either using ConsoleCast to create an access point or configuring it to join an existing Wi-Fi network. You can buy one for $49 or 45 euros, but the schematic is open source, and if you're so inclined, you can make one yourself. The cool thing is that NickStick made ConsoleCast open source, so you can modify it to your heart's content, which is why I want to support their effort. Practically everything happens in the ESP32 microcontroller, which is the S2W Rover type with 4 MB of memory. On the left is the SP3232E, which is a level converter supporting 2 inputs and 2 outputs and converting them between plus minus RS232 voltage levels and digital logic level. The caps are for the charge pumps to get the necessary positive and negative RS232 voltage levels. Here we have some protection diodes for nasties coming in from the USB, indicator lights for TX and RX. This part up here is the power supply circuit, which is relatively complex. Normally this electronic switch here connects the USB V-bus to the charger for an 18650 cell. The battery, or if there isn't one, V-bus through this diode is connected to the power switch. If turned on, it connects to a voltage regulator that produces 3.3 volts for the processor. NickStick added a novel way to see how much charge is left in the battery. When the power switch is turned on, this capacitor is charged. The lower the voltage, the longer it takes before the voltage on the base of this transistor is enough to turn the other transistor driving the power check LED off. The result is that when you turn the unit on, that LED provides a single flash that gets longer the lower the battery gets. It's a rough indication and only done when turning on, so one needs to learn by experience when it's time to recharge or replace the battery. Apart from the serial port, ConsoleCast can also be used to connect devices using USB CDC mode to communicate. Because CDC mode requires that ConsoleCast is the USB host, if that mode is selected, the V-bus R signal from the processor is used to reconfigure the USB port using the electronic switch. V-bus is then connected to the output of the boost converter, which is fed from the battery. So for normal serial port, you can either use the battery or feed the unit from the USB, and if the battery is inserted, it is automatically recharged. But for USB CDC mode, you must have the battery inserted, and it supplies not only the ConsoleCast but also the device hanging on the USB port. Finally, down here are some different connectors, USB-C here, and the RJ45 that is used for the serial port here. At the bottom is a patch field that allows connecting the RJ45 pins either for a Yost style cable or a different style simply called patch cable. This part is maybe a little confusing, but it's well explained in the ConsoleCast website. First of all, you need to recall that even though we only have one serial port, the hardware supports 2 RS232 inputs and 2 outputs. That is because the unit supports hardware handshake using the request to send and clear to send signals. A set of 4 jumpers on the PCB allows to connect the TX, RX, RTS and CTS to either these pins on the RJ45 connector or the other pins if Yost is selected. Yost, by the way, refers to Dave Yost, who suggested this pin out in 1994, and it has been adopted by many manufacturers, notably Cisco, for their console ports. Here's the holder for a plain, and I mean unprotected, 18650 cell. On the top we have the electronics protected by a transparent plastic cover. Most prominent is the fairly large ESP32. On the left of the on-off switch is the RS232 level converter and then the patch field for the RJ45 pinouts. On the very right, past the ESP32, NickStick put two buttons which are essential for developing new software. EN resets and, together with boot, commands the bootloader to download new firmware over the serial port. This means the ConsoleCast itself can serve as a development board for new firmware. How much current does it draw when in serial interface mode? The battery is nearly full at 4.12 volts and the current is close to 90 milliamps, which is relatively high, but nothing a half-decent 18650 can handle for a couple of hours. I thought it might be interesting to see the novel battery voltage indicator in action. The panel meter at the bottom displays the voltage. Watch the flash of the power check LED directly above it for 4.2 volts. About 6 video frames or 0.2 seconds. The flashing red-green RxTX lights are part of the initialization of the firmware. Repeating the same with 4 volts, about 8 frames or 0.26 seconds. I got the same 8 or maybe 9 frames for 3.75 volts. And 10 frames or 0.33 seconds for slightly above 3.6 volts, but that is obviously too low already because the init looks weird and it never finishes. So we have a flash range of about 0.2 seconds for a full battery to 0.33 seconds when it's already too low. I don't know about you, but I would have a hard time detecting that by eye. After contacting NickStick about it, they confirmed that the power check circuitry needs to be revised. As it stands, you need to check the charge state through other means or, as I do, always recharge after use. Another thing I want to mention, if there's no battery inserted, the unit rests stable on the battery holder. But with a battery inserted, it actually now rests on the round lithium battery and wobbles. But that can be easily fixed by replacing the nuts with a 50mm long M3 hex standoff. And now the unit doesn't rest on the battery anymore and is stable. To see it in action, I turn it on with the serial port connected to the XTM1041. There's a very slow staircase voltage going into the XTM1041 just so it shows some values that change every few seconds. Once the access point ConsoleCast AP appears, you can connect to it. There are usually some grumblings of browsers not liking the self-signed certificate for the secure connection, but the ConsoleCast website explains how you can make your browser accept the certificate. Once ConsoleCast is running, it starts a small web server, and now you can open a web page using https://cc.local as a link. That gives you a page allowing configuration settings as well as a terminal window for debugging. I can set the baud rate manual, for example, and open the terminal window. Typing the usual *idn ? Command, which you can't see because it's not echoed back from the XTM1041, brings the ID of the multimeter. And typing MES ? returns a single measurement from the main display. While serial communication is in progress, you can see the red TX and green RX lights flashing briefly. At 115,200 bits per second, this is very brief and sometimes the camera shutter may miss it. If you want to know more about these SCPI remote control commands for the XTM1041, check out my GitHub page on the meter, which has a list of all commands, link in the description. The default firmware allows more than type commands in the terminal window. It implements WebSockets to allow programs to communicate with ConsoleCast, changing comms parameters and sending and receiving data. You can download a sample program from the ConsoleCast GitHub page to run in your browser, which communicates with an O1 XTM2041 multimeter. The same code works with the XTM1041. All I had to do was modifying the serial port settings because I run mine at 115,200 bits per second instead of the 9,600 that was coded in the example. What happens here is that every second the WebSocket program in my browser sends a MES ? SCPI command over Wi-Fi to ConsoleCast, which in turn forwards it over the serial port to the XTM1041. The measurement is returned over the serial port to ConsoleCast, which then sends the result over Wi-Fi to the program on the laptop for display. This is of course very rudimentary, but you get the idea, and the WebSocket interface can be incorporated into more sophisticated programs. Another way to run this is not to create an access point, but configure ConsoleCast to join an existing Wi-Fi network. This is all very nicely explained in the ConsoleCast website. This is the ConsoleCast GitHub page, which has the firmware source code and hardware information, including the schematic and the example of the XDM2041 WebSocket program that you just saw. What about the USB CDC interface, you may ask? Well, it turns out that I don't have any device that has a compatible interface, so I can't demonstrate it. It seems that some network switches and power supplies have it, but I drew a blank when looking around my lab. But here's the point. The firmware source code is all available for modifications and enhancement, and an open source developer framework for the ESP32 is also available. And there's tons of documentation on the ESP32S2 that is used in the ConsoleCast, including a massive technical reference manual of more than 800 pages. So I could just create my own version of ConsoleCast that uses my own SSL certificates and that implements a USB interface in a way that's compatible with devices that I have, for example my Rygold DS1054Z. I do admit that will take time and it won't be part of a video for some time. To summarize, ConsoleCast has been developed to allow network access to serial ports either in traditional form or as CDC type of USB devices, mainly for typical network console interfaces. I will use ConsoleCast for a different reason, mainly to enable data logging while being electrically insulated from the measuring devices. The fact that ConsoleCast is battery powered makes it ideal for this. You have seen logging from the XDM1041. That is in principle what I have in mind, but for the XDM1041 and most other multimeters with a logging capability, this is not needed because the logging interface is already electrically insulated from the analog input. But this is very much an issue for most mains-powered oscilloscopes as well as for my Fieldtech FY6600 function generator. If you need to use them floating, that is not connected to mains earth, you can't connect a USB or Ethernet cable that is connected to your mains powered PC. ConsoleCast solves that problem. To preempt a lot of comments, I'm well aware of other solutions to provide electrical isolation between two devices, including optocoupled USB to USB adapters and USB to Bluetooth adapters. But ConsoleCast is a neat alternative, with the advantage of being fully programmable. Okay, that's all for now. Don't forget to subscribe if you have not already, and maybe consider becoming a Patreon, link in the description. As Patreon you always get early access to videos, a blog and other exclusive content. Thanks for watching.